In this video, I'll be taking you through chemistry, which is a box on HackTheBox right here. So just come to machines, then you'll get this chemistry box. So chemistry is a box on HackTheBox which focuses on vulnerability in the PyMartigen library, which is a Python library which allows for the execution of arbitrary code when processing untrusted input. And later on, we'll go ahead and exploit a directory transversal vulnerability on async IO HTTP server to grab the root flag. So that's just a little bit overview about this chemistry box. So let's get to it. So grab the IP address, then let's come here and let me show you my nmap findings. So I did nmap with TAC SC for default script scanning, TAC SV for service enumeration, and TAC PN for no pinging, and TAC A for a thorough scan. Then the IP address, you have it here. And the nmap scan discovered port 22, typical SSH open, and this port 5000. And this port 5000, because of the thorough scan, it got back the web page right here. As you can see, we see this HTTP, so that's a web server running there. And here we have this particular web page. So what we'll do, we'll open up a new tab and check out that particular web page. So just paste the IP address, then it's on port 5000 as we've seen. So let's check it out. Okay, here it's loading. Okay, and here we have our web page right here, chemistry CIF Analyzer. Welcome to the chemistry CIF Analyzer. This tool allows you to upload a CIF crystallographic information file and analyze the structural data contained within. So basically, crystallographic information file is a standardized file format used for representing crystallographic data of small molecules and inorganic compounds. So what we'll just do, let's register here and see. So I'll use let me do test 1023, then a password. Okay, and here we are greeted with a dashboard. Please provide a valid CIF file. An example is available here. So we have this, meaning we should be uploading a file, and we have this, I guess will show us the files that we've uploaded. Then you have this logout button. So let's okay, just a little bit. So let's download the example file to see what it looks like. So just clicked here, it's here downloading. Then let's check it out. So here it is, double click on that. So here we have the CIF file. So basically this is just this CIF file just defines a basic structure with a hydrogen, as you can see here, denoted with this H, and this O, oxygen atoms. And this is a simple crystal structure that could be representing something like maybe a H2O molecule, water molecule in a crystallized state. But that's not relevant to whatever we are for this particular box. This was just an example file. So let's get back here. And now that we've seen the type of file that you should be uploading to this particular web page, let's check for a CVE, a CIF CVE. So CIF CVE, that's the first thing to check if we can, because when we see an upload like this, we should be thinking about uploading a reverse shell. So let's check if there's a CVE. So right here we see this particular arbitrary code execution CV with the CIF. So let's check that out. So here we have that particular CV arbitrary code execution passing a maliciously crafted Jones faithful transformation string. So here we have the bit about this CV, and let me just give you a quick overview. This vulnerability comes from the PyMargen library, which is a Python library, and PyMargen is just an analytical tool that can study materials such as metals, polymers, and crystals. So the vulnerability exists in this particular where it is this particular function here, Jones faithful transformation, and this method takes a description of how material is transformed and turned into a language the computer can understand and work with. So this particular method right here it is. It utilizes the eval method. So eval is a function to execute arbitrary Python code, and thus giving room to code injection attacks in the system. So this vulnerability emerges immediately uh, that that input string transformation, this right here. So here is where it the vulnerability emerges right here in this particular eval method. So we have this POC, proof of concept, right here. So it says the vulnerability can be exploited as follows: create a file named val.cif with the following contents. So what we'll do, we'll grab this, copy that, then let me come back here to our shell, and I'll use mousepad. Then let's name the file, let's say exploitx.cif, because it should be having a .cif extension. Then let's paste that right here. So here we have this type of file, kind of similar to what we have here, and at this particular point right here is where we should be attaching our reverse shell. So let me just delete that. Then I'll come back here and we'll go to rev shells. So rev shells are sites to generate reverse shells. So let's just go to rev shells real quick, and I'll give a disclaimer. For crafting a reverse shell for this particular box, you should use busybox. So these other shells won't work. Bash plain won't work. Use busybox for this particular for crafting this particular reverse shell. And the reason why we're using busybox is because busybox is super lightweight and is optimized for working in constrained environments. I tried working out with bash plain. It didn't, because bash shell sometimes doesn't work because it might be relying on external utilities such as netcat, while busybox has a built-in netcat to initiate reverse shell. So use busybox for this. So what I'll just do, I'll come here, grab this particular one with the busybox, then let me put my IP address, which is 10.10. Okay, 10.10.14 14.14. That's it. Then we are listening on port 1023. You know what's up. So let's grab this. This is the one-liner reverse shell. So I'll just copy that. Come back to our mouse pad right here. Then we paste it in between these double quotes right here. So here we have it. Then click here to save that. And let's go back here. We need to, in a new terminal, let's set up a netcat listener. So LVNP for listening verbose mode, no host resolution, and port to specify the port 1023. Then let's get back to the other shell real quick. So here, let me just okay, let's first check if it's here. Okay, I meant to do an LSLA. Okay, we have it there. So I'll just change the file permissions real quick. I'll just do 777, then the name of the file. Okay, now I guess we're good. Okay, then the next thing that I'll do, I'll get back here, and upload the file. So yeah, this is it. Grab it there, upload it. Okay, and as you can see, it's right here. These are showing us the files. Then click view. So when you click view, you're supposed to be getting a reverse shell back. Let's see if we have a reverse shell. So yeah, we see it's connecting right here. So let's give it a moment. It's still connecting. I can just try to do something like ID to check. Okay, we are in. So the next thing I want to do is try to stabilize this shell. So I use Python 3 command, then import pty, then pty.spawn, just making the shell a little bit interactive. We're trying to spawn a bin bash, so close it right there. Okay, now we have a little bit stable shell, as you can see. So the next thing that I'll do, let me first go to the root directory. Okay, let me do an lsla. Then let me cd to home first. I just want to check something real quick. Cd to home, do an lsla. Okay, we have this particular rosa user. Let me check to see what we have in a rosa user before. Oh, we have the user.txt. So right here, let's cut this user.txt. Permission denied. Okay, because you're not rosa. Okay, my bad. Okay. Let's go back and lsla. We'll get back as the rosa user and get the user.txt flag. That's no worry. So let me see what we have here. Okay, we have home, blah blah blah. Okay, let me see. Let me again try to go back to, let me see something real quick. Yeah, let's go back to the app user, lsla. Then let's cd into this instance. This is where the juicy stuff is. And lsla real quick. Then you have this database.db. So let's read what's in this database.db. Okay, and as you can see here, this database contains password hashes. So there are different users. There's Maxell, Crystal. We have different users here. Robert. Then we have Rosa. So since Rosa is the user that we have in this particular machine, we'll grab Rosa's password hash. So just copy that. Then we'll try to decrypt that, and we'll do that over the, let's use CrackStation. So I have CrackStation right here. These are good websites to decrypt hashes. Might be MD5, whatever, NTLM, just anything. So let's paste it right here. Okay, then we need to solve a captcha here. So yeah, we're not robots. Okay, let's give it time. Okay, the captcha took a little bit of time, but here it is. So now let's crack the hash. Okay, and that was pretty fast. So it was an MD5 type hash. So let's just grab it, copy it, and since we have this user, what we'll do is, okay, let's get back to the other terminal right here. let's switch users. So let's do switch user to Rosa. Then for password, let's use what we've copied, paste it right there. Then immediately we are in as Rosa, so we can do ID. Who am I? Just to confirm we are Rosa, as you can see right here. So now that we're Rosa, I guess we can now grab that particular user.txt. So cd to Rosa, okay, cd to home and cd to Rosa. Do an LSL, okay, I meant LSL, but whatever. Then let's now check the user.txt. Now we have permissions, and here's the user.txt flag. Okay, didn't mean to do that. Copy that. Let's submit it. Okay, paste that, submit that. Processing. That should be okay. Flag on. That's beautiful. Let's get back here. Then now we need to proceed to our our privilege escalation phase, our foothold phase. So while we're in here, we can just do net start to check what else is running up on this machine. So I'll just do net start and list whatever is also running up in this machine. So real quick, we see right here we have this particular on port 8080 we see this HTTP alt. So there's seems like there's something here. So we can just try a curl request. We can just try to curl to see what's happening. So just do let me move the cursor, localhost on port 8080. Then let's curl that and see. So when you curl that, we get this, which seems like a web page sort of. Okay. Okay, well, we can even do this. Let me try do this. Can close that. We don't need that. We also don't need that anymore. So let me open here and do localhost on port 8080. Just want to see what's okay. That can't work because okay, for that to work we need to do port forwarding, of which I don't want to do right now. We need to port forward that, but okay, what I'll do because we're not going to go the port forwarding route, let me try. I want to try curl and check for the HTTP headers. So localhost over port 8080, then I'll do head. So this particular command is useful when you want to check if your server is running or if you want to inspect generally the HTTP headers. So something such as the content type or anything that is in the HTTP header. So that's just that. Let's do that. So here we have this particular information here. As you can see, content type, content length, the rate, and here we have the type of server that is running behind this web page. So that is this AIO HTTP version 3.9.1. So these are these async IO HTTP. It's a popular asynchronous HTTP client and server framework for Python, built on top of Python's async IO library. So what you can just do, grab it that way. Then when you see things like this, you just come here and check if it has a CVE. So that's the first thing you want to do each time you meet anything. So then I'll do CVE. Let's check for that. So right here. What am I seeing? What am I seeing? What am I seeing? Let's check this one right here. It's taking time to load. Okay. This seems to be giving me a bash script, which I'm not interested in. Let me see. It's loading here. It's a bash script. I'm not interested in that. That won't give me the overview of what's happening. There is this other website I want to check. Let me see. Yeah, this one here, a deep dive. Yeah, this will give us the a good overview of this particular CVE. So it's loading. So here we go. We have it here, CV 2024. This is a recent CV actually, 23334. I deep dive into HAIO, HTTP's directory traversal vulnerability. So as I said earlier on, these are directory traversal vulnerability. So here we have this. I'll link this in the description below. You can read about it. But what is of interest to us, what we want to do is this call request. So let me just grab this. I'll grab that and copy it. Come back here. Let me try pasting that. Okay. Okay, but we need to change the port. It's running on port 80. Then we are looking at assets, not static. We're looking at assets. Then check let's see. We're checking etsy password file, I guess. Okay. I didn't add a quote right there. Okay, give me time. So since I'd messed the machine right here because I never included end of quote right here after this password right here parameter, I had to close the machine, set up a netcard listener again, and just to let you know, if this happens to you, you need to first go back and go back here. Let me show you, because some of you might go through this. You have to go back here, delete this file that you have here, upload another one, then click view, because if you use the same one for some reason it doesn't work out. I had to go through that, so just delete the one you have initially, upload another one, then view to get to catch a shell back. So let's get back here, and now that we know better, let me grab that, copy it, I'll paste it there, I'll include the end of quote. And as you can see here, we have the etsy password file right here, and yeah, you can see we can also try to grab the shadow file. So just paste that, then looking at etsy shadows. Okay, the same problem again, so give me a sec. So in my quest to check for the etsy shadow file, I went through the same unfortunate incident again, but I'm back again. As I told you earlier, just go through the process that I mentioned, delete the exploit file, then re-upload another one, then set up your netcat listener, and click view, then you'll catch a shell right here. So what I'll do, I'll just grab this to show you what I wanted to show you, checking out the etsy file. So I'll copy that, and this time I'll try to be very meticulous with this. Okay, just grab it and it went this way. Okay, now this is really crazy. This is messing me up. So now that I'm back for the second time, what I'll do, this time I'm wise. I'll grab this because I really need to show you guys this shadow file. So I'll grab that, then I'll do it from let me do it from my mouse pad here. uh, okay, yeah, let me paste it there, put that end of double quote, grab it from here, copy it, then let's get back to our shell, then now let me paste it. Now we are sure it won't mess us up. So as you can see, this is what I wanted to show you guys. You can also grab this particular HC shadow file right here. So yeah, you see, we have this. So this is some beautiful stuff. So since we can do all this, that just means typically we can also just grab the root flag from here. So let me paste that, then I'll just do root, then root.txt. This should also be just okay. So guys, this is the third time I'm messing up the shell, but I'm back again. I guess I'm just super exhausted, but here we have it now. We are making a color request the same way we were doing on this particular, on the Etsy shadow and the Etsy password files, but now we're doing it to the root directory to check the root.txt, to grab the root.txt flag. So yeah, and you can see we have the root.txt flag. So let's submit that. Paste that right there and submit. So yeah, so basically that was chemistry. Uh, Super intuitive box. I learned a lot about the crystallographic information file, and also the other CV to do with the async HTTP client and server framework, the Python framework. So yeah, that was chemistry. I'll see you in the next video.